Hello. Good morning. Hello.
Hello, good morning.
Good morning.
Hello.
I can hear you, please. Abraham.
Yes, good morning, sir.
Good morning, Abraham.
Fine.
Dr. Nazir.
Yes, good morning. I can hear you.
Good morning, sir.
Good morning. Good morning. Can you hear me?
Yes, I can hear you very well.
Okay, thank you. Good morning.
Is there anybody from Faculty of Computer Science, Physical and Computer Science, please? Is there any person from, is there any one of you that is part of the organizer, local organizers committee, please?
No, actually, me, I'm not.
Okay, don't worry.
I'm coming from Bauchi, Federal
Okay,
University of Medical
you're
Health.
welcome. You're welcome.
Thank you. Thank you, sir.
Good afternoon, everybody.
Morning, sir. This is
Okay,
morning.
morning over there in Nigeria.
Yeah, good morning. Please, who is speaking? Siraju.
Dr. Muhammad Siraj Abdullah, Department of Mathematics.
Good.
Yeah.
Are you the local organizing committee?
I can't say exactly,
Okay.
but I know it is my department.
Okay,
But
no problem.
I'm away from.
Okay, good.
I wanted to be
This is
part of.
Luan Mohammed from
this
MIS, please.
Okay.
I'm trying to connect to the local organizers committee so that I can give them the host right.
All right. Let me see if I can get one of them. It's already time.
It's already time. Come in.
I'm Rahman Taylor.
Good morning, sir.
Good morning. Can you put off your mic?
No, I'm not with my mic.
I mean the noise. The noise is coming from your system.
Yes. What up now?
I think the noise is normal.
Okay.
Hello, good morning, sir.
We already have about 10 people.
Hello. Yes. Professor, good morning, sir.
Assalamu alaikum.
Walaikum salam.
Assalamu alaikum. Everyone, can you hear me?
Walaikum salam, Prof. I don't know who is the. I didn't see the speakers. Hello, sir. Can you hear me? Hello, Prof.
Dr. Sraj, you are welcome. You're welcome. Influence. Bangari
Rilwan is here close to you, sir. You will see Faculty of Computing Science.
Okay. So, what option? Anybody with fly? Can you manipulate and get the flash drive? We have more than 12 people. Yeah, he wants to copy. Or if can, well, yeah. Okay, I can rush to go and get you. Maybe because of the way. Kokatura email. Okay. 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 Alternatively, I need just 3 minutes to yeah. Maybe you can come and somebody should come and keep in case there will be questions. Somebody will ask something. Maybe if somebody pops in, then you address them.
Many people are online. Many people are with us. Now almost
14. We have 14 in number.
Okay. What? Email or WhatsApp? WhatsApp. Okay. Maybe it's heavy.
Dean. My Dean, please. Hello, my Dean.
Okay, including yours.
Assalamu alaikum, Prof. Assalamu alaikum, Prof.
That's what I'm thinking of. Oh, sorry, he's here.
Samuna,
Which number?
Okay. Anyway, it will pop on. Let me just wait. It will pop on.
How about Abdul?
Are you using this network here?
No, I'm using what? I'm using my network. Akwai network there, amma na sa cable din is not picking up.
Assalamu alaikum, Prof.
Save his number.
Hello.
Abdul Karim, Ate Abdul. Okay, so wait a minute. It should be Abdul is here. Abdul is here. They is yet to pop in. Just a few minutes, it will come.
Send to my phone.
Where is the presenters, please? Who are the presenters?
Okay.
Hello.
You can also you can join and present from your system. You've joined, but great. So you share your screen.
Yes, share.
Okay. I think my name is
Dr. Abalun, please.
Hello.
Hello, Dr.
Have you sent
Abalun.
your
Can you hear me, please?
Okay.
Yes, I can hear you.
Ladies and gentlemen, we are going to start very soon. We have a few technical issues, but in the next 2 minutes, by the grace of God, we are going to start. Thank you for your patience. Right there. It's like, but this is
Let me send it to you.
my problem. Let me see if I put it on drive mode, if I will get the network, so that people will not call. If that's the case.
What's up?
Oh, okay. That means we have to get it here.
Check your WhatsApp. sent it.
It's yet to download.
That is for Abdul
Yeah, for Abdul Karim is ready. Maybe it's heavy. How far?
It's around 62 MB.
62 MB is heavy.
So can we share the screen?
People that here sharing.
Yeah, but somebody said I should come back. I thought you got an alternative.
You're now sending through WhatsApp.
Okay.
Can you not share this your screen?
Share screen.
It shows like only the host can see my screen. Maybe if someone can join here.
Yeah,
See if you
but
can see
on
my
the alternative, if I can see your screen, then I share it so that everybody will see. On Abdullah.
Until you can't share until you download that thing.
No, from his own screen, I can share.
Why not just share? You can find share mine will stop sharing. No, sir. Since it's sharing, you can.
Yeah, but it's only the host that can see him. That's the comment we had here.
Only host. No,
I think it's setting.
It's in the setting.
Okay, let me call them so that they can. Call Akaram one so that I will not distract my network. Relwan. Akaram is aware. Actually, setting in so
Let's go back to WhatsApp if it's downloaded.
Got it.
Can we convert your presentation to PowerPoint to PDF?
Okay, let me see.
Like animations.
I'm more comfortable using it now. Or alternatively,
Flash.
no, I need a Kaoshima. I don't know in the Ganosh. Okay, Abdullah Naka. Okay, now.
Assalamu alaikum, Prof. Sir. Hello.
We can.
Yes, try it. Have you done it? If I can share.
Yes, it is shared. Let me just. Why not? Can you join the link again? If you can see my screen, if you can see my
By
screen.
sharing.
If you can see my screen.
It's okay. You can see my screen. Great. So just continue. So I think we are going to start. Prof. Okay, thank you. So, movement. Public lecture. Okay, your camera is
To any Bamagani for the similar manner as a Mahaba. In your coma, give big. Okay, so you apologize.
Assalamu alaikum. Please, I wish to apologize for starting this program late. It's my pleasure to welcome you all.
Okay. Continue.
Assalamu alaikum. I wish to apologize for starting the program a little bit late. It's my pleasure to welcome you all, Faculty of Physical Science, and the seminar slated in the Faculty of Physical and Computing Science, which will be held today. To begin with, we want to start with the opening prayer said by our Middle Past Dean, Professor Oko.
Alhamdulillah.
Second is a welcome address by the Dean of Faculty of Physical and Computer Science, the name of Professor Garba.
Thank you very much. Okay. Thank you very much, the faculty seminar coordinator, the chairman of the occasion, participants, the presenters, staff and students, ladies and gentlemen. It's a pleasure to organize this maiden seminar from our all boys. The presenters, the first presenter is Malam Manuel, who's a PhD student working on data science in the University of Limerick, Ireland. Then second presenter, Dr. Abdul Karim, is also going to make a presentation on a topic as earlier distributed. So we are indeed happy to have them around on break, and we felt we should make good use of their presence, and consequently the need for this maiden seminar. This seminar is first of its kind since the faculty has been created, which was carved out of the former Faculty of Science, comprising of 5 departments. And the occasion is going to be chaired by Professor Esio Gulumbe. So I hand you over to the chairman to coordinate the presentation. Thank you very much.
Okay, the chairman of the occasion, Professor Dombe, father of the faculty, please over to sir.
You are need to move there also?
Yes, sir. So that you can see.
Oh. Why don't you show
No,
them?
because of the
Table,
issues, sir.
Okay. Good morning, my dean, my colleagues, my students, my whatever. It's really a very good start. I'm really happy to be here as chairman of this maiden edition of a faculty seminar. For sure, data science nowadays, and the internet of what we call internet of a thing is very important, very crucial and reigning. In fact, whoever is an expert in data science globally is a hot cake. It's a hot cake. Why? Because anything you can think of doing, you need data. And managing that data, using that data is very important. It is from data that you can plan, just from data that you can take a decision, and it's from data that you can do, I can say, almost everything. So one cannot underestimate the importance of data science. Data science actually is also wide. It has so many components. And alhamdulillah, today, we have two presentations. One titled Data Science, Trends and Applications. And the other one is global collaborations and networking in research also. So in a sense, the two are interrelated. And by the grace of God, we will see what they have for us. And I'm quite sure by the time we are done with these two topics, we'll go home happily, having learned something about data science. Good and fine, we are starting. And I'll take this, that by the time we finish with this, I would like the faculty in due course to arrange for a workshop, particularly on data science. We explore so many things. I'm quite sure there are many people that would like to know about data science and what have you. And by the grace of God, we'll do something about it. And I'm quite sure people will enjoy it. So, with this short remark, I will say welcome to the first speaker, who is Maniru Ibrahim, one of our sons on PhD, who will give us talk, as you have seen there, on data science trends and application. Happy listening. And I welcome Maniru Ibrahim. Thank you. And Alhamdulillah, my fathers, mentors, teachers, my fellow postgraduate colleagues, good day to you all. I'm really happy to be here in front of my fathers and my mentors to discuss about data science trends and applications. So the first thing I will discuss about this topic is, I would say data science is for everyone. I will just give an example from the center that I am in, the SFI Center for Research and Foundation of Data Science in Ireland, where I'm doing my PhD. In my cohort, 11 students were admitted to the data science at the University of Limerick. Out of these 11 students, 3 are from mathematics, 3 are from computer science, 2 are from statistics. 2 are from statistics, 2 are from physics, and 1 is from psychology. So we can see how diverse. We come from many different fields, and we are all doing our PhD in data science. So data science is for everyone. Everyone can apply data science in his research. So I will start with some thought exercise. So the first exercise is, suppose that we are given a set of building data. Let's take Usman Danfodio University as an example. We are given all the buildings in Usman Danfodio, the energy usage, the occupancy pattern, and the building materials in the university. How can we reduce the energy consumption here? And also the carbon emission while still maintaining the occupant comforts? And we can do this through data science. Second thought exercise is, suppose we are given a disaster response data, which includes emergency response time. For instance, let's take the hostel, for example, that we used to have most of the time, fire outbreak. Suppose we are given the data that if a fire outbreak happens, how long we have the data, the fire service go there, the resource allocation that we have, the communication channels. How can we improve the response time? How can we allocate resources more effectively and save lives during this, and save life and properties during this the fire outbreak? And also this can be done using data science. The last I will talk about in the thought exercise is given a set of medical data, including like patient history, his genetic data, clinical trial results. How can we improve the diagnosis accuracy and treatment outcome for diseases such as cancer or diabetes? So all this can be solved using data science. But let's go, what is data science? Data science is an interdisciplinary field that involves the extraction, analysis, interpretation of data using statistical and computational methods. So people used to say data sets, they are just like magicians. We will give them an unstructured data. They will try to take the structured data, make it into structured data, analyze it, and interpret the data and make a decision based on that data. And why is this data science so important? We have to look at how data is in the world. There's one interesting fact that said, did you know by 2025, it is predicted that there will be 175 zettabytes of data. That is 175 followed by 21 zeros. That's the data we have. So it is important to study this data and make decisions based on these data. So, but before we dive into it more, as we know that data science is kind of a new field, we have to know the component, what come and give us the data science. So I will start with this Drew Venn diagram for data science. So in the Drew diagram is just explaining that the data science is an intersection between mathematics and statistics, knowledge, which is used to formulate the formulas and the experiments. Then we need the hacking skills. What I mean by hacking skills here is like the computer skills, programming skills. After you have your mathematical formulas, statistical formulas, methods, you need to program them into computer. And you have some substantive expertise. Maybe you are in the healthcare sector. need to have that expertise that will use this tool to make an experiment or make a research or do some analysis based on that. So that's the components, the mathematics, hacking skills, and the substantive expertise. So as the topic is data science trends and applications. So now let's go to the trends of data science and see. There are many trends in data science, but I'll just mention 4 here. So the first I'll mention is the artificial intelligence. So the artificial intelligence is just the ability of a machine to perform tasks that typically require human intelligence, such as, like, if I see my prof here, I can recognize him. How will I teach computer that when a software or computer see an image of prof, it will recognize, yeah, this is prof. So also speech recognition and decision making. So all these are in part of artificial intelligence. And one fun fact about artificial intelligence that I'll say here is that AI had been used in developing self-driving car, the car that can drive itself. It can, and one, I think I have a friend that is doing project in this self-driving car. And what she's doing is trying to have a 360 view for the self-driving car. That the self-driving car will have the view from the left, from the right, from the back, behind, and in front of it. I think which is more efficient than the human, that you can only see the front and the side. So AI is really making some revolution. Also the diagnosis of disease, and there is development. I also know someone that is doing research in MRI scanning, that how can I teach machine that if MRI machine perform a scanning, how can the MRI machine also analyze the scanning, know if it is a fracture, what type of fracture is this? What are the recommendations? What decisions are supposed to be taken? So all this is due to that success, and even creative art. We can ask a machine to create an art for you. Well, secondly, is machine learning. Machine learning is just a subset of AI which involve training algorithm to learn from the data and make prediction and decision based on explicit programming. So machine learning is just like we are giving. Let's just take COVID-19 as an example. Like, we have the past data of COVID-19. We have the past data that this day we have, it's just like time series. Let me give an example of time series. We have like the time series data of the amount of cases, the cases of COVID-19. How can we predict the future? How can we predict the future? Or we have maybe the resources that we are allocating, that the bed that we are allocating for the COVID-19 patients. How can we predict the amount of bed that we require in the next 10 days, in the next 10 weeks, in the next 10 months? So this is all about machine learning. And one fun fact about machine learning, it has been used to predict stock, identify fraudulent transaction in real time, and also used for diagnosis of cancer. The next trend I will talk about is big data. Big data refers to large complex data set that can be processed using traditional processing methods. So one fun fact about big data is that Facebook collects more than 500 terabytes of data every single day. So, and most of this data cannot be processed using traditional methods. So this is also interesting area in data science. As if you look at the social media now, I know a research on predicting flood using Twitter data. How can we respond based on the comments of the people? And there are many comments. Each keyword is a data. And how can we study that? Then finally, data visualization. So data visualization is just the process of presenting data visually. So one fun fact about it is that the famous infographic on Napoleon Russian campaign in 1812 was one of the earliest examples of data visualization. Let me show you the infographics. This is an infographic done in 1812 during the French and Russian War. And the thickness of this is showing how large the army is, the French army is.
And when they arrive at Moscow, you can see that they kind of reduce. That's how they are losing them as they arrive at Moscow. So this just shows this one of the earliest example of data visualization. And let me give also an illustration of data visualization. Suppose you are given this data. Let's take this is a travel insurance data. And this travel insurance, they have the, whenever you go into their website, check for travel insurance, they give you a code. You have to put this following details. You are what time, your age, employment, you are graduate or not, annual income. Do you have a travel insurance or not? Most of this. So, and maybe after the COVID, they decide that people now are not traveling much. And what we have to do is that the amount of money budget for our advertisement, we want to reduce it into half. And they gave you this data, this is our data. What will they do? Who are the people that they should focus on? What age classes should they focus on for their advertisement? Since now they have a low budget. So suppose they give you this data, maybe it's containing 1,000 rooms. By looking at just this data, I don't think it will be difficult for you to give them a suggestion of what they do. So that's where the data visualization comes in. Because if I like, I can just visualize it like that. Visualize it like that. For instance, I will just visualize frequent flyers and those that have a travel insurance. And I can see that most of the frequent flyers, I can make a decision that most of the frequent flyers, I think I made a swap in this because this is supposed to be yes and this is supposed to be no. So it's showing that most of the frequent flyers, they have the insurance. So I can say that my suggestion for you is that you should focus on frequent flyers more for your advertisement. And this is all with the help of data science. So the next I will talk about applications. As the Faculty of Sciences, Faculty of Physical and Computer Sciences having 5 departments. So I decided to give an example of application in each of the departments. So the first I start with mathematics. So I start with mathematical modeling. Data science has been used in mathematical modeling to model complex systems, such as the model for predicting spread of COVID-19 and predicting the efficacy of different vaccines distribution. Also, it has been used in optimization, how to, in transportation industry, how to find the best route to travel, documents, and other things. And one example, I did not write it here, but let's take partial differential equation, for example. In partial differential equation, we used to have like a very complex models that have high dimension. And these models used to be reduced into reduced order models to solve them. But with the help of data science, many people have used data science in order to use this, because this result reduced model, they are just approximation of the full model, because like full model, you cannot solve it, or it's very difficult to solve. You reduce it into approximation, and this approximation have kind of a less accuracy. But with the use of data science, scientists, mathematicians were able to even use this data science to improve the accuracy of the reduced model and also the efficiency of the model and make it more faster than the other one. And it's also been used to solve the Navier-Stokes equations, which is 100 times faster than using the traditional mathematical method. Also, application of data science and statistics. I used to say that data science on statistics. So I'm still talking. So what I will say is it has been used in sport for prediction of outcome of the game and performance of individuals. Also, it has been used in the mining the healthcare data and the electronic health record and to identify the risks of a person having disease. Maybe we have people with diabetes, take their record, all their health record, their trials, clinical trial, their genetic, their almost everything. And based on that, we will look for who are at the risk of getting a disease. So, and this all have been done in statistics. The next is computer science. So in computer science, I will talk about natural language processing. One thing I will say, this is my area in data science, the natural language processing. And this has been used it's been used to make a machine to recognize the human language. For instance, let's just take Siri, the iPhone Siri, that if you like, you can just ask Siri, Siri, I want this. Let's take the biggest example now, ChatGPT. You can ask ChatGPT anything, it will give you a response in time and all other things. So the next is computer vision. So computer vision, data science also is being used for the self-driving cars, I've said, to detect objects and avoid obstacles on the road. I'll just give an example on this computer vision. There's a student in my department that worked on computer vision, that he developed a software that if you put a camera in an industry, in a working place, it is using computer vision that it will recognize, it will detect if there is something that may cause injury. Something that may cause injury. And when he did that, for one example is the bombing of train in the railway in Kaduna, Abuja. Suppose that we have that software, it will easily detect and alert that there is a bomb here. So when he developed this, then he decided, what I want to do, I want to make this a patent, because I don't want to just make, I want to have a startup based on this. He pitched, he got investors, and I've told you, the boy, our director of our center have to say to the student, I think you need to drop the PhD and pursue this. He dropped the PhD. And when I calculate by, I think, just last 2 months, the company in Naira is now worth more than 15 billion Naira. So there are many opportunities in data science. All this PhD research and this, I know in my school, they have more than 100 patents that developed. And most of these are based on PhD and lecturers that do it. Because if the PhD finishes this PhD research, he will think of what can I develop? What startup can I develop based on my research? So next is physics. So physics, it has been used to the properties, behavior of black holes and other celestial objects in astrophysics, and also the study of subatomic particles such as quarks and leptons, which are very small particles. So then in geology. So in geology, data science has been used in geological surveying to analyze and interpret data for remote sensing. And it has also been used in geology for detection of deposits. Like if you are looking, it has been used in a case study to find in which area can we find carbon. We have a land. How can we detect where can we have carbon? Even in agriculture, there's some kind of smart farming that you will use data science will be used to look at which land should we cultivate on and what type of plant is best to be cultivated in this area and at which time. So this all in the help of data science. So now let's talk about the benefit and impact of data science on research, as almost everyone here is a researcher. So it enables more efficient and accurate computations, as I gave an example for using PDEs when you're solving like Navier-Stokes equations. Also new discoveries and insights, because sometimes you will be doing research, you will be doing pattern by your manual research. You can only see what you are doing there, but you can ask computer to study more deeper than you, and it will come with some insight and discovery that you even didn't expect. Also, it gives a better prediction, such as weather, pattern, stock prices with greater accuracy and more effective decision making. Like I gave an example for the insurance company. So with the help of data science. And the last one is increased collaboration, as Abdul is going to discuss about it. But data science increased collaboration so much. As I'm a PhD student in data science, but my research is, I can say, is in pharmaceutical science. And this is all because of data science. Because my PhD research is on studying the drug dissolution. How, when you take drug, how does it dissolve in your body? How long is it take? What are the processes there? How do we design drugs? And my BSc is mathematics, master's is mathematics. I'm doing PhD in data science, and with the help of data science, I think I can even move to pharmaceutical science now. So this all, and there are many collaborations. Like for instance, let's take maybe someone from physics, maybe develop an MRI that can use a scanning machine, maybe a portable scanning machine that is the size of this, and that you can use to scan, do some X-ray. He can collaborate with computer scientists or statistician or mathematician to see this software that you develop, I will add something to it. I will add the cognition for it. I will add that if it sees an image, it can recognize this is a fracture. There's a fracture, there's no fracture. Then I can use natural language processing and other things. And I say, so the computer science can use the natural language processing and say, interpret this, explain what happens to the leg after you take the scanner. And all this can lead to several collaborations. So next, I will talk about data science in academia. There's a post by Jan van der Plas, where he discussed the data science and academia and data science, and he posed the following question. The first is, where does data science fit within the current structure of university and research institution? These are something that we need to think critically and also share on perspective on them. What do academic data scientists need in their career? How can academia offer what academic data scientists want in their career? What are the drivers that may shift academia toward recognizing and rewarding scientists in their domain? And how do you prepare best graduates to success in both academia industry, as some of the graduates will work in both fields? So these are, and we can also think of our academia. How can we improve? For instance, we can use a machine learning or anything to see that how can we get the data of the students? The student, what is the student involved in the maybe academic and support activities, his grade, his demography, is he living in the hostel or at house, and see what students are at the risk of not graduating. Which student, and how do we improve? How do we try to improve those students? So all these data science, and we can have small projects that we can focus on. If a student do research, let's try to see, can we make this a patent? Can we build a startup with this based on this research? Because almost all the research in data science, most of them, you can build a patent on them, most of for what I have seen. So next, I will just discuss about some case study and close. So the first case study I will discuss is election, as we are approaching elections. So I think it's the best one to discuss first. So let's look at Obama campaigns in 2008 and 2012. What Obama did is social data. He used social media and data mining. What he used is micro-targeting. What he uses is that they will study your profile in Facebook, your Facebook profile. Who are you? What are your friends? What posts do you like? What do you post? And try, like Cambridge Analytica, when they did that for Trump in 2016, they said that they have almost every person that is doing Facebook in America, they have 5,000 data points on that person. Who are your friends? Who are the friends of your friends? What are the habits of your friends? What do they post? What posts do they like? People say, as they kind of know you more than you know yourself. And based on that, what they do is that based on what they know, they say, what we'll do, this person will know the message that we'll be sending him. We'll know the advertisement that we'll target to him so that we can convince him to vote Donald Trump. And Obama used almost similar things. And I know there's a very, very serious case about that, about the 2016 election, because they use data science, but in the bad way. So the next is fraudulent detection. Also, machine fraud detection using data science is widely used in finance, insurance, and e-commerce companies. They used to detect who should they give loan to, and if they used it in real time to see if there's any chance of having a fraud. They will try and alert them and try to block the fraud. So, example of company that used it is PayPal. They use machine learning and rule-based algorithms to detect the fraud in real time. And I'm just showing some process here that what they usually do: collect the data, prepare the data, extract the features that they need, build a model, evaluate the model, and then deploy the model. So the next case study is cancer, which is a complex disease. Cancer, with a single tumor of cancer, there's over 100 billion of cells, and each cell acquiring mutations individually. So, and cancer is constantly changing over time. But using the big data analytics and high-performance computing can help identify the pattern in cancer. We can study all this 500 billion cells using big data, and also try to see the pattern of the cancer. If the cancer is spreading, how long, how is it going to spread in the time, with time, and what direction is it spreading to, and how can we cure it using the data science? And also customer analytics, which I think is one of the things used in data science nowadays, like Amazon company. For instance, let's just take a YouTube. Whenever you go to YouTube, watch a video, most of the time when you go to YouTube, they used to give you something that are related to you. So, and all this is with the help of data science. Like Amazon, they are using customer analytics to study their customers, what their customer usually buy. Based on what he's usually buy, what is his purchase history, customer, even his browsing, what does he just search in their website. And based on this, whenever he enter into their apps, log into their app, they will try to recommend something that they think he may like. Then in conclusion, data science, we say, is rapidly growing and transforming the way we analyze and interpret data. And also it can be used in the math, computer science, statistics, economics, almost every field. Also, one of the key takeaways is data science enable us to make sense of large and complex data. Like I give you an example of the insurance data. You may have a data that my first project when I went to Ireland, I was given a data that have more than 1 million. It is a time series data of the weather of the island. And what we are asked to do, and it contains several missing data. We have to study the data and see how can we generate electricity to the island based on using the offshores, the ocean. Can we generate electricity from the oceans? And we study this data, we develop a model, and we even do the cost analysis, how will it take government cost to do this, and what is the return, and how many years government will return their money and start getting profit. So this all with the help of data science. And if you are interested in pursuing career in data science, and there are many resources online, as I can see, I teach myself data science. One example, when I was doing my master's, my master's more of pure mathematics, not even applied mathematics. We are doing pure mathematics. But when we went to the project, I just take one course on numerical linear algebra, and I decided to myself, I'm interested in this data science. And I think in my master's, I'm the only one that did master's thesis in data science, because all other people do it in pure mathematics because the program is on pure mathematics. And I taught myself that, and with that project that I did, my master's thesis, I was able to get the scholarship with it. So everyone can teach himself data science. And in data science, you can develop patterns. Like I'm currently doing my internship with one of the top industry in the world, Tata Consultancy Service. They have over 600 employees in the world. I'm currently doing several projects with them, several projects for the companies, and high-level projects with them. So thank you.
Okay.
Thank you very much. This is Manil. I said it, and I've been vindicted. Data science, I said, is everywhere, it's for all. Even people from Gumi. And
I don't know it's around.
This is interesting. And we thank you very much, Manil, for this wonderful presentation. I don't know, we have some few questions or comments.
People that are online.
Yeah.
Yeah, online. We have people online.
We have people online.
Okay.
Yeah.
There are many, about 24.
Okay.
Okay,
Yeah.
we have questions, I think. Okay, maybe let me check to see if I can address.
So people online can type their questions.
I think the problem is
Okay, maybe those online can. Hello. Yeah, somebody is requesting to make a comment from Aminu Baya. Yes, Prof. Aminu Baya, go ahead, and you said you have a comment. Go ahead, please. Unmute yourself and make your comment, please.
Are you hearing?
Okay, you can as well chat. Yeah, please make your comments online so that we can make it public. Okay, you can unmute yourself as well, but let me see if I can.
I think it's random.
He has given me co-host. My only trouble. It's not giving me the listen. Yeah, unmute all. That's what I'm trying to do. Unmute themselves.
Yes.
Hello, good morning. I've been able to unmute myself.
Okay, Prof, you are unmuted. Please, you can make your comment.
Okay, good.
Yes, you can as well write, please.
All right. Hello, assalamu alaikum warahmatullah.
You should write, in fact, since we are not hearing him. Okay. Yes.
Hello, can you hear me?
Okay, alternatively, can we take the next presenter so that people can write their questions? Yes, yes, please.
Can you hear me?
Yeah.
Hello.
So,
hello, can you hear me?
for the benefit of those online as well,
yeah, we can hear Prof. Bayawa.
Second presenter, and then at the end of the day, we'll have the questions.
It looks like
all together.
It looks like those on ground cannot hear.
So
we
can hear you.
Yeah, we can hear you.
Yes,
yeah, you can hear me. Those online can hear me, but those at the venue cannot hear.
He has the screen here. He has his own here, I think.
I think there is problem there.
Could it be that their audio is muted there? I mean, their device audio, the output speaker, maybe.
Yes.
Hello, Prof. Can you hear? Prof. Garba.
Since they can hear.
Yeah.
Okay. The second presenter, Dr. Abdul Karim
Hassan.
Dr. Abdul Karim Hassan. And Dr. Abdul Karim Hassan is going to talk on global collaborations and networking in research. Yeah, Dr. Abdul Karim, you are welcome and happy listening.
Hello. Hello.
I can just jump it. I can jump it.
I'm meeting man.
Good morning, everyone.
Ahmad Uba, can you unmute yourself?
Yes.
You are interrupting. Ahmad Uba.
So we have
can
to
you
share
mute
this
yourself?
screen.
Good.
Hello?
Yes.
Ahmad Uba, you are on mute. Please, can you mute yourself? You are a bit of interrupting the presentation. Yeah, thank you.
I want to take this. Okay, this one. Huh? Yes.
Ahmad Uba, babies are
Yes.
talking on your background. Could you kindly mute yourself, please?
Yes, I did.
But we can hear you.
Can you
hear
hear
sounds
me?
coming from your angle. Please try to put yourself on mute. Thank you.
What do you want? I want to take this off. Take it down. Is there a way I can hide this? You want to hide? I want to hide this. Okay. It's like, can you manage it like this? It's okay. Okay. Good morning, everyone.
Dr. Abba,
My name is Abdul Karim Hassan Ibrahim.
Can you
Today
put
I'll be
Ahmad
giving a
on
talk
mute, please?
titled Global Collaborations and Networking and Research. I would like to start by acknowledging the presence of the Dean of Faculty of Physical and Computer Sciences, who is the mentor to my mentor, Professor Isa Derba, and also the Dean of Sciences, Professor Koko, the head of department, Associate Professor Halima Usman, the coordinator of the seminar series, Professor Biwa Isa, my teachers, fellow colleagues, I greet you all. So, my talk today will be very brief due to some constraint. When I was invited to give this talk, I thought it would be something more of mathematics. Unfortunately, I saw global collaboration and networking and research. But since our fathers have summoned us here, we have no choice. We have to answer their call. So the outline of my talk. Can you see? So the outline of my talk today will be as follows. Okay. I'll start. The outline of my talk will be as follows. I'll start with a brief introduction about myself. Then we'll go to the main topic of discussion, which has to do with research collaboration, networking. Then I'll discuss a little bit of my PhD thesis and research project I want to work on, and if there are possible students who are interested in joining. So, I completed my Bachelor's of Science in Mathematics in the Department of Mathematics in the year 2017. During my undergraduate days, I worked in the area of combinatorics and graph theory. So my thesis was published during the course of the studies. I was able to author and co-author 2 articles published in some journals. And during this period, I was privileged to obtain the PTDF scholarship from the undergraduate students. And as well, we were able to represent the university in the National Mathematical Competition for university students, where we came 7th out of 34 universities that participated. Four students from our department represented the university in the competition. My name was part of them, Fatima and Stephen. And each one of us came back with a medal. We came back with 2 silver medals and 2 bronze medals. So in 2018, just when I was about going for NYC, I secured the Petra Prajam Cloud PhD scholarship to study for a PhD in applied mathematics at the King Mongkut University of Technology, Bangkok, Thailand. So my PhD thesis was in the area of numerical optimization. So I worked on approximation methods for large-scale unconstrained optimization problems and nonlinear equations with applications. So my mentor in Thailand was Professor Pum Kumam, one of the first percent scientists in the world. My research experience, I was a visiting researcher at the Department of Mathematics and Informatics, University of Novi Sad in Serbia. And also, I was also a visiting researcher at Erzurum Technical University in Turkey. Currently, I'm a postdoctoral fellow at the Interdisciplinary Research Center for Smart Mobility and Logistics in King Fahd University of Petroleum and Minerals in Saudi Arabia. I'm also a research associate at the Department of Mathematics of Pure and Applied Mathematics, Sefako Mediato Health Sciences University in South Africa. Thanks to my mentor, Dr. Kazim Aremu. I'm also affiliated with the KMUTT Fixed Point Theory and Application Research Group, Department of Mathematics at King Mongkut University of Technology, Tomburi in Thailand. And my research interest, as I said, is in the area of numerical optimization. I have interest in iterative methods for solving nonlinear equations, unconstrained optimization problems, variational inequality problem, signal and image processing, and related topics. So over the years, from 2018 to 2022 or 23, let's say 4 years, I've been able to publish a total of 65 research articles. 65 which are indexed, you can find in Google Scholar. 52 of these articles are indexed in Scopus databases of not less than Q4 quartile. I can say 75 of these articles are in the Q1 and Q2 quartile, and 45 in the Web of Science database. I have citations of 461 on the Web of Science database, 476 on Scopus, 720 on Google Scholar, 15, and 18 as H-index respectively. So how do I achieve all this within a span of 4 years? I think that is why the organizers have decided to give me this topic, global collaboration and networking. This success is only recorded through collaboration, research collaboration. My mentor would always say, if you want to go fast, go alone. If you want to go far, then you go together. And this is the reason why I have all this much. So now we'll go into the main topic of discussion, global collaboration and networking and research. What is this collaboration? Collaboration in academic research is usually thought to mean an equal partnership between two academic faculties who are pursuing mutually interesting and beneficial research. But in the actual sense, collaboration is not limited to this notion. Collaboration has involved researchers of different stature, funding status, and type of organization coming together to work together with the purpose of achieving mutual interest. So there are so many variations of collaboration. We can have collaboration between members of two research groups in different departments of the same institution. For instance, research between the Department of Mathematics and that of Computer Science, research between Computer Science and Statistics, all these are possible. In another way, you can have research between companies, private companies and institutions. For example, Manir is doing something like that. He works with private organization companies and is also affiliated to his university. These are the kind of research, these are forms of research collaborations. And another form of collaboration is by sending students to other universities to work with other faculty members who are experts in another area. For example, when I was doing my PhD, I traveled to Serbia and Turkey to work with other professors. So why do we need this collaboration? Nowadays, funding agencies, they need researchers who have a very big network and collaborators. To be honest, it is not expected for a researcher to come and apply for a grant alone. You need to have collaborators and other colleagues who are ready to work together with you in order to achieve the success of the project. And that is why you need a good number of collaborators and collaboration. Secondly, you need collaboration because difficult problems require bigger and more selective teams. If you have a big problem, for example, I'm working in optimization precisely. I work on an unconstrained optimization problem for solving an unconstrained optimization problem. Nowadays, research in mathematics, if there's no application, it's more or less useless. Nobody wants to consider this. So how can we apply our work to real world problem? There is need for collaboration.
the pure mathematician alone cannot understand this application. That is why you have data science nowadays, you have machine learning. So you need people in that field to understand what you're doing. Then you apply all these algorithms, our work. We can now synergize them and apply them in solving this real world problem. So how can this be achieved? This can only be achieved through collaboration. So in most of our work, we have collaborators from computer science, statistics, mostly, sometimes from physics and chemistry as well. So how do you find academic collaborators? We can find academic collaborators. Now, if you're thinking of applying for a grant, it is important to find collaborators for your research projects. You want someone who is well equipped with your project and someone who can contribute to your ideas and expertise. So one of the ways of getting collaborators is through conferences, going for conferences. When you go for conferences, you find colleagues in different areas in the same discipline, but in different areas, and you'll be able to identify who is suitable for your research projects by attending conferences. Another way is through journal articles. If you read research papers daily, all the time, if it's a hobby, you always find new research ideas, and you will always be able to identify the authors, because in research articles, you always find the emails of corresponding authors, sometimes all the authors. You can easily contact these authors and make a research collaboration with them by simply sending an email. For example, sometimes in 2022, August, I saw a research paper titled Accelerated Dial Projection Method for Solving System of Monotone Nonlinear Equations with Application to Image Deploy. When I saw this paper, I got an idea from the paper, and I decided to contact the authors, one of the authors, and I sent him an email. My name is Abdulkarim Ibrahim. I work on iterative method as well, and I've read your paper, and I would like to collaborate with you. The content here are sensitive, so I decided to hide it. So I told him what I wanted to do, and I asked him if he's interested in collaboration. If you are interested in collaborating with me, please let me know. Thanks in anticipation of your prompt response. Favorable response, Abdul Karim. He responded, Dear Abdul Karim, sorry for the late reply. I'm currently on vacation with my family. I'm coming back from vacation in August. I'm interested in collaborating with you. If it suits you, we can start August 16th, and the rest follows. This is a way of making academic collaboration. Again, through social media, academic social media, not the Facebook social media, academic social media, like LinkedIn, ResearchGate, Researchers ID, and so on. There are many of them. So I'm more interested in LinkedIn because it's more flexible for research. You always find a lot of researchers there. I've also tried to make contacts through LinkedIn, and I got very good response. As a professor, you just have to be bold sometimes. It doesn't matter the statue. Just be humble and send the message. They might reply you. Some might not reply you. It doesn't matter. So I sense he's working on something different, but there's a relationship with what I'm doing. And I decided to contact him as well. And he responded, certainly, Abdul, we can do. It may be a very good idea. And he said, this is what he will do, his contribution. This is what he will contribute. And all these collaborations, we have drafted our manuscript and they are submitted under review. So how do you build a research collaboration? Before you can build a research collaboration, of course, you must have an idea. You don't expect them to look for you. You must have the idea, then you look for them. So I already had the idea. That's why I went to look for somebody in my direction. So you must have the idea first before contacting the potential research collaborator. So when you have your ideas, then you identify those people that your research interests align together. When you're able to identify them, then you have done most of the work. You only need to write to them or try to convince them why they should work with you. So that's it about this. And also networking is very important in research collaboration. As a researcher, you should be active. You should be active in some sense. You should at least attend conferences, workshops. You can also send emails, and you should also be on the network platform of academic networking platform. Like I said, LinkedIn, ResearchGate, Research ID, and Mendeley, and several on. So networking now. Research network means a network intended solely to support research and development of new and or enhanced products and services. So why do we need this research network? You need research network to circulate your working papers for comment by scholarly community, research for collaborators, reputation building. So as a researcher, it is important when you write when you publish a paper, who are the people reading these papers? Who are the people looking into the papers? Is there any contribution to society? Is anybody using these papers to do anything? So you can only sell, for example, if you want to sell food products, you go to the market and sell your product. If you keep it at home, nobody will come and buy. So the same thing with research papers. When you publish, there are so many journals. So when you publish your papers, there are specific places you are expected to upload those papers in for visibility. That is only when people can read your papers. So what are the academic social networks you can use? Academia.edu, ResearchGate. This contains a lot of articles and a lot of subscribers, but I still prefer the ResearchGate and Academia.edu. LinkedIn for researchers and so on. So how do you enhance your visibility as an author, as a researcher? If you want to enhance a very good visibility, one of the major things that has to be considered is your name. My name is Abdul Karim Hassan Ibrahim. I'm writing a research paper today. I use Abdul Karim Hassan Ibrahim. Tomorrow I'm using Ibrahim Hassan Abdul Karim. You will be lost. Your profile, you will not be able to, your papers will not be in one, there won't be arrangement in your papers. Today you will see a paper in one database, tomorrow you cannot find it in another database because there is no consistency in the name. So as a researcher, we must always make sure we have consistency in our names. So another way to create visibility now is by establishing presence in databases that are very important for research, such as the Scopus database and Web of Science. Nowadays, let me give an example. If you have a pharmacy, if you make drugs, and these drugs are not NAFDAC registered, will you be interested? We know that the local drugs are good, but you have more trust in the drugs that are NAFDAC registered. So the same thing occurs in the research environment. Publications that are not in Scopus or that at least Scopus or Web of Science are not usually considered to be very good in terms of research. In fact, sometimes when you make a presentation, when you take your references and your journals are not in Scopus, nobody wants to listen to you. So it's very important. Also, I talked about the name, consistency of the name. Now, the OSCID ID, if you have a problem with names, this OSCID is a solution to that problem. It gives every researcher a unique ID. Whenever you're submitting your research articles to journals, when you input this ID, using the OSCID ID. So it's a very important feature ID. To enhance the discovery of your research, you have to publish in index journals, at least the Scopus and Web of Science. Increase dissemination of your research by publishing in open access journals. Most people will say you increase dissemination by publishing open access, but I have my own reservation to open access journals because they need a lot of money, funding. You have to pay for publications. And sometimes paying for publications is just as if you give in. It's just like a market. You want to sell. You send your paper, you have the money to get published. The peer review process is not very, rigorous like the closed access journals. Yes, although the closed access journals, they are hybrid journals, which are both open and closed. Irrespective of which of the access you want to use, the review will still follow the normal procedure. So, I want to talk a little bit mathematics, my research project, and anyone interested can contact me. So, I said one of my problems is working on unconstrained optimization problem. This is a basic unconstrained optimization problem. Minimizing a function f of x, where x is an Rn, and associated problem of finding f of x is 0. This small f is from Rn to R, and this big F is from Rn to Rn. Why are we interested in this problem? Most of the models that occur, that comes up in engineering and other fields, they can be easily modeled into non-linear equations or minimization problem. So we are interested in solving this problem because of their application. They have application in machine learning and so on. So there are so many early methods for solving this problem, including the Newton method, Gauss-Newton method, Levenberg method, among others. And this method are very popular for solving this problem due to their superlinear convergence property. They converge fast. For example, if you have an asthma patient that uses an inhaler, example, you have an asthma patient, and this patient has an attack. If you have an inhaler that will help him cure that attack in 5 minutes, and you have another inhaler that will help to reduce the problem in 5 seconds, which will you prefer? So that is why you need a very fast convergence of your methods. So for every method we use on solving all these real world problems, we're interested in the time because it's very important. Now, it is well known that some of the first optimization methods, that is the conjugate gradient method, optimization problem. However, so the conjugate gradient methods is one of the first order optimization methods used for solving large-scale unconstrained optimization problems, and it was introduced in 1952 by Hastings and Stiefel. And some of the properties include low memory requirement, global convergence, simplicity in implementation, efficiency in solving large-scale unconstrained optimization problems. So, because of these good properties, several researchers have extended this method to solve nonlinear equations by combining them with the projection methods. So that by combining this method with projection methods, they became derivative-free method. And this method has an iterative recursive formula. And this recursive formula is sk plus 1 equals to sk plus alpha k dk, where this alpha k is a step size and dk is a search direction. This alpha k, this step size is computed using some line search strategy. And the popular line search strategies are this. So this method, they require computation of line search. So the computation of this line search and the search direction dk here is computed using this formula. Dk is negative gradient of gk when k is 0, and negative gk plus beta k dk minus 1 when k is greater than or equal to 1.
Nasiru Muhammad,
So no, the problem now is
yourself, please.
The computation of line search makes the work implementation computationally expensive, because at each step of iteration, there's need to compute the value of considered mapping, and also you need to check these inequalities. You need to check these inequalities many times, which makes them computationally expensive. So what we want to do is we want to develop efficient iterative methods for approximating the solution of large-scale nonlinear equations by exploiting the structure of some first-order optimization method, projection method, and some acceleration techniques. So the goal is to develop iterative method with global convergence properties under realistic assumptions, and also all this the development methods should be implemented and tested extensively on benchmark test problems. Furthermore, the methods will be tested extensively on suitable applications arising in science and engineering, such as logistic regression problem and transportation problem. Thank you for your attention.
Thank you very much, Dr. Abdulkarim Hassan, for the wonderful presentation.
Yes, that's very good. As I have said also, you see the whole thing now, you can see they are interweaving. Collaboration, data science, everything together. So God bless you. Now, for those that are online, they should post the questions. Those that are online, post their questions.
Okay, so let me go through.
Yeah, okay, go through. And then maybe after that, then those that are present here, we can follow them, then have some discussion.
Okay. Thank you very much, Mr. Chairman.
So I can sit with it?
Yes, you can sit, sir. So we have a few questions here online. The first one is from Abdurrashid Alami, and he writes, Assalamu alaikum, good morning, everyone, and many thanks to you all. I think this more or less appreciation than question. Then the second one, also he said, thank you very much. I think that's... Okay, this one said, thank you, Abdul Karim Hassan. This one said, please, I need the contact of the last presenter. So collaboration has started. So collaboration has started. I think we can share. So this one is only requesting for the contact of the last presenter. So we need your contact. We'll tidy them up. I think it's better we drop it. We'll drop your emails here on the chat. So can you help us type your email so that we solve that problem once and for all? This one, I want to make a comment, Prof. Yeah, I mean, please go ahead, make your comment. Unmute yourself and make your comment, please.
Hello, assalamu alaikum wa rahmatullah.
Prof, can you unmute yourself, please?
Yes, I have unmuted myself.
We can hear him. We can hear
Yes.
him.
It appears, I don't know, your speaker is not functioning well, but actually those online can hear me. And I have unmuted myself, obviously.
Yes, sir, we can hear you.
Yeah.
Okay, just 1 minute. It's on. No? It's on.
Connected to this.
So can you hear me now? I think it is your speaker that is.
Okay, those online can hear you.
Okay.
There's no mic.
He's unmuted. I mean, I see him here.
Yeah, he's unmuted.
He's unmuted. So, okay, Prof, go ahead.
Yes, can you hear me now?
Yes, we can hear you.
All right, thank you very much. Allow me first to start my. There's a lot of echo.
Okay, go ahead, Prof.
I think, Prof, you have to mute yourself to avoid the echo.
I've done that. There is no echo now.
All right. Thank you very much, Prof. Let me start by congratulating the faculty for this very important initiative. And I think this is the way to go. We have to get in touch and help other members of the faculty to come on board. This is what we have been trying to do at the directorate level, Directorate of Research and Development, so that actually we do what we are meant to do. I always say that the fundamental, even though we are employed to do, we are said to be employed to do research, we also share knowledge and then we apply it. Basically, that's what we do. But the heart of all this thing is actually research, because it is through research that we generate new knowledge. Without generating new knowledge, then hardly we have something to share with our students and with the rest of the public. And also hardly we have something new to apply. So I will congratulate the faculty for this. And specifically, I would like to also congratulate the Department of Mathematics. It is very joyful to see that some of your products are out there making it very heartwarming. I would like to further advise the presenters. They are doing very good researches in wherever they are in their places of research. But I would like to advise them that please, as you are out there doing your research, publishing, getting high citations and what have you, learn not only your subject area, but also learn from the environment. We would like to see that in the near future, you come back home and help other students that are coming up to impart that knowledge you have acquired. This is what the Chinese people have done. This is what many other countries, and still they are doing, actually, the Chinese people. They send their people out there to learn things from US, from United Kingdom, and then they come and perfect it at home. So it's not only going out there to make some money and to do some research and get citations, but most importantly is to acquire the knowledge and come back home to help in the development of your country. This should be the target, actually. So I would like to advise them as they go out there, please don't forget home. Learn as much as possible. Learn about how they do things. How do they get things right? How do their universities work? And all such kind of information, which when you come back, you can apply here to make our things better at home. I would also like to suggest to also advise or to reiterate what the last speaker mentioned. That is the issue of collaboration. As you are out there doing your research, please do not forget your lecturers and other colleagues that are working here at home and collaborate with them. Do collaborate with them, please, in whatever research you are doing. And when opportunities come, do contact them to get them on board in such collaborations. Scout for opportunities. Scout for opportunities, please, as you are out there, not only for yourselves, but for your lecturers here, for your universities. If there are opportunities, for example, to go into some memorandum of understanding between the university where you are working or the institute where you are working and this Usman Danfodio University, Sokoto, we are going to be very happy to engage in that, provided it is going to benefit the university and the departments, the affected departments. So please scout for opportunities for us, for your lecturers and for your other colleagues that are working here back at home. And then I would like to say back here at home, we have a lot of people that are specialized, that have specialized in various areas. But the problem, one of the major problems I understand is that we don't come together. The last speaker during his presentation, he mentioned that when you get into this kind of research, you have to get people from other areas involved. People from chemistry, people from physics, people from other areas that are relevant to the project at hand, get them involved and collaborate. We don't really have that here at home. I know currently we are having a project that we are working on with Dr. Boy. We have people from biochemistry, we have people from here in chemistry, we have people from the computer science that we are working together, people from microbiology, we are working together on a particular project. There is need for this. we have to come together and really understand ourselves. And one way to do that is really this kind of presentation that are happening in the faculty at the department. We have to be attending them. It is from there that you come to know that this person has a particular specialization in a particular area that is relevant to your research, and then you get him involved. But if we stay away from each other, things will not go as we want. So thank you very much. I would like to finally also congratulate the speakers for these wonderful presentations. And I hope maybe we will escalate this maybe to the university level. If we, by any chance, at the Directorate of Research and Innovation, we intend to organize a series of lectures that will target particularly the younger academics. And being them very young, we would like to engage them in such kind of activities, and I believe they will be very much ready to work with us. So thank you very much, Prof, for this wonderful initiative, and I hope the rest of the faculties and departments will also get on board and continue in this direction. Thank you very much for the opportunity.
Okay, thank you very much, Prof. This Professor Aminu Bayawa is the Director of Research and Innovation of the Osman Danfodio University. Thank you very much for your wonderful comments and encouragement. So we'll take note, and we also hope the speakers have taken note of the observations. And let me also, with the permission of the chairman, keep in a few things about mentorship. This is a result of the mentorship that we motivate every department to embark on. I still have their book. They wrote the 104 indubitable set of students. Within this set of students during their graduation, we have about 4 first-class students within that set. It was during the, what do you call it, parallel sessions. So the first and the second session, we have about 4 of them. When the university was invited for a quiz competition, I felt this at the first student. In fact, the university doesn't even know. I used my car, we went to Measurement Medical Center, had competition, they won medal, they came back. They were motivated. We used to have classroom tutorial with them and with some of the staff of the university within one class. So consequently, some of them, in fact, yesterday was he said to undergo his national service and he has finished his PhD. These are the result of the mentorship. So they were mentored. Monique Ibrahim got the largest grant ever in Africa, about 20 million. So that one is not for your consumption, but for your motivation. So this is quite motivating, quite encouraging. All the 4 students are abroad, all of them for their affinity. Fatima is in Marshall University, Akinola. In fact, she got 4.4 over 4.4 GPA for her master. She was the best graduated student in Marshall University. She has gotten her PhD in US again, fully funded with assistantship. Stephen also the 4th person. These are the only 2 that came around. The 4th person also got the best. In fact, he braille a little bit. He changed from mathematics to fiction, right? Fiction writing, and he got the ever best African award in literary writing. So but he's now coming back to mathematics. I think I had some discussion. So he has gotten those awards, he's coming back to mathematics. There's a role for his PhD. So he has gotten the funds and is going for his PhD now. So this tells a lot about mentorship. Yes, please. And he has finished the PhD. Correct. So these are some of the motivations we want to encourage our colleagues to embark on. I read one book, Judge Polio. He said 10 commandments of a teacher. So one of the commandments, he said the teacher should be able to identify the student that needs his attention most and those whom he should need their attention, so that he should motivate them and encourage them to excel. They can help. We are getting tired. So we need students that can pick up from where we stop. And this, I believe, is one of the ingredients we are getting from our students. They've excelled, and we are getting a lot. And I used to have discussions with them, almost everyone, and them to advise on how we should improve, most especially as it relates to a collaboration, so that it can improve the ranking of the university. So I really appreciate all your effort, especially our father here. He taught almost everybody in this class that you see, Professor. With me as a graduate assistant, I'm always proud of him. So these are some of the mentorship we expect from everybody within the faculty and even outside. Identify students, mentor them, continue contacting them. Don't just allow them to go without contact. Keep in touch with them. motivate them, encourage them, advise them on the right thing to do. This will tell a lot on you and even after your life. So thank you very much, Chairman, for the time spent.
So I think
okay, we can still have
we
questions.
still have some
Questions.
questions. Yeah, Doctor.
Yes. Okay, thank you, presenters. My first question is for Maria. I see that you're doing some partial differential equation using data science. I know we have a very strong area in department. Dynamic students using partial differential equation in their team. So I want to know, how can you collaborate, or how can you help us help the students to start thinking of this time as you are using currently? That is one. Two is that I don't know how possible to do that. Your center here, can we have maybe our faculty here have a partnership where they can help us set a data science club students here, that the students here can come through project and interact with the
Let me say with the second question about the selection. As I know the center, they're very nice people, and I don't think they have problems with collaboration, but I'm traveling to Ireland, China this week. So maybe I will try when I go there and discuss with our director and see if there's anything they can share. About the partial differential equation, like there are two things that the first thing that I would say is that, like in my own research, I have the first thing I'm doing is if I have I develop a PDE model. I have my partial differential equation with the boundary conditions. So what I do is that I'm modeling. I will look for. I'm collaborating with the solid synthesis pharmaceutical center there. So they will give me the data of their experiments. They have the data. Then I will check my partial differential equation models and fit the data and see how they fit the data. Then I will use data science to try to optimize my partial differential equations so that they will fit the data. So that's one part of using the partial differential equation. The second part I'm trying to use it, I haven't used it yet, but it's the reduced order model. If I have a complex PDE that have like 3, 4 dimensional, 8 dimensional, whatever. So what I'm trying to do is, how can I use the dimensional analysis like PCAO something data science to reduce the model and try to then develop the PD again on the reduced order to see how do the two compare. Like it is an approximate of the full model and see because the reduced one will be much more faster. Because I know there are sometimes that if I run my PDE model, I have to use to run it on Friday, and I will leave my computer there. I will come back on Monday to see if that's finished running. But if I can reduce this to the small or to the reduced order, you can maybe solve it in 10, 15 minutes, 1 hour. So, and the third thing that I'm doing is I'm using machine learning. What I'm doing is just doing PDE model, get the drugs and try to. So the second thing that I'm doing is that I don't need the PDE models. I have my PDE models. I'm doing comparison. What I just need is I have this drug. I need the structure of the drug. I'll use convolutional neural network to see the drug, to teach the computer that this drug is having this dissolution number. Maybe the solution is 2 point something. This drug is this drug is this. And I will teach the machine like with 1,000 drugs and their dissolution. Then I'll give the computer a picture of a drug, a structure of the drug, chemical structure, and I'll ask it. It has never seen the drug, what is the solution? And one of my, the friend of my supervisor is one of the students used similar things on several things, and he found out that even works more better he compared it with the partial differential equation, and it even works more better than his partial differential equation. So there's several ways. I will try to discuss with my
second person. First, to advertise, project to advertise, interesting, and I don't know, can you put a bounce on it so that our subscribers can be interested? That is one. Second is that suppose we want to have a summer school, Sokoto-Kevisam, particularly from our graduate students. So, can you help us in setting up that summer school, and then we start leading facilitate of suspects? How do you just want you to bring something back for? So we are looking at having summer school.
For the first question regarding the bounty for the research project for postgraduate students, of course, we can set some incentive for postgraduate students, but there are conditions attached, of course. So perhaps the student has to publish an article in top quartile journal, at least Q2. If they can achieve that, they can earn as much as 500,000. And for the second, of course, staff also contain. And the second question regarding the summer school, of course, it's always good to give back to the community that have invested in us. So it will be an honor to do that. But the constraint will be the time factor and the mode of the summer school. Will it be online or on site? And also, if it is online, we have time differences in the various places we are. So if we can make an arrangement, a suitable arrangement, it's possible.
Is it possible arrangement? Yes. What do you want to do? Just add operational costs. Okay. Yes. Your name and then.
My name is now I'm very glad to be. My question is, so you talked about thinking about the computational. I want to, and I can see that this and the focus of all discussion is based on the graduate student. So I would like you, we can consider the undergraduate students. In Usman Danfodio University, we have some undergraduate students with fire burning in them that they are really willing to work as a research assistant, do research, because me now presently our publications of machine learning, mental illness and accident. Sure. And I have several students like I come like 5 of us like that. We are just we have publications like that in data science that are working very well with other universities. We'll be very glad to work with you.
What I can say about this is, like we are in a group of 5. I'm currently working with some of the people here in even Sokoto that I know when I come back, and I'm even having a meeting today. So what I usually say is that the 5 of you, let's take the cashless policy that we are having here in Nigeria. Sit the 5 of you, think of, is there any solution that you can do, that you can bring? And the solution, it may be profitable. Maybe you can do some wallet. What I usually, this is from my experience with my internship. The first thing they ask me when I go to the internship, give us an idea. What idea do you have that to solve? And I told them this is, then they modify the idea, and we are developing some very serious, important patterns that, so I think that's my advice.
Yes. My name is and there is a science center Operation is one of I was saying when you show me patients like that, send some grants and then see people the area. I think it's what should not miss out this time around.
Okay, maybe if I can comment on that. Okay, let me comment on that before your second question so that you know, the retention is getting weaker because of age. So actually, this I said primarily from where once on a committee writing requesting for Center of Excellence in Data Science in this university. We've passed 5 stages, we've passed 4. So the 5th one that we were knocked out as a result of quick collaboration. Now we are also working on another project that we have also about 2 million units. I hope this was offered. We are competing with. When we posted this, one of the members said, I shouldn't forget to give you because I have the template. So the collaboration is considered done with all the history. We have the template signed. So immediately after this project, I'm also making a very good point. This presentation now is going to be part because they requested for educational activities. I'm going to sign. Their profile is going to help me. I'm going to give them the letters so that they can also. So, like I'm keeping 10 parts with one stone by their people. So, collaboration is very, very, very important. And make you get that's that other people. And it will make you lose one.
Yeah, about yeah. What efforts? I heard about money. It's interesting what you say so likely see any more after it's a very good effort. What I'm saying about paying back to the university, being expanding your network and mentorship also, but paying back to the institution that grooming in terms of either the staffs, exchange program going to the university to get the exposure and come back here. Because I've seen a very, you have said yourself, told us about yourself. But one thing that is missing is your linkage with the university department. We want to see that linkage happening. When you are smiling, Abdulkarim is frowning. Yeah, it's interesting to see how some of you will likely show that they are really. I've gone through your thinking, but I didn't see much emphasis on this one unfolding, rather than emphasis a lot on classes that you are doing, which is also a bonus to the university because now visibility of the university is in terms of that. So we want to see more emphasis on that Usman Danfodio University because like Upper Gulev, wherever you cite it, you see that first degree, you will emphasize that is his foundation. Yeah, like Kasarawa and Co, you see that Usman Danfodio is giving us a lot of visibility because now top 100 nephrologists in the world, Kasarawa is one of them. Yeah, you can see how it is fetching the university a lot of visibility. So we want to see more of that. Like that. And for your mentorship. For people that have mentored, you know, they are saying they are old, they are going. So wake them up before they retire so that they can actually get some of that. Yeah, and it's good. Now it's an eye opener to the department, to the faculty now. We should look inward ourselves in terms of supervision. That's where collaboration starts.
We ended up major supervisor, second supervisor, third supervisor, only our interest. Our interest is just the graduation and have promotion. And that is the first beginning point of collaboration. It's an eye-opener to all of us. That is the beginning of collaboration as far as academic collaboration is concerned. When we change that, we will indicate toward all other collaborations that will likely come up. Yeah. But I think it's interesting, people in computer science, you know, there was a lot of argument. Data science is for everybody. Data science is for everybody. But ideally, collaboration is one of the key factors in data science. You can't do it alone. You can't do it alone. So interesting projects and collaborative projects are multidisciplinary, not simple project that one direction. So it's multidisciplinary. So I think it's very good. The mentors to this gentle. You guys have done very well, but at least Karim, anything that you pay back to the yeah. So yes, no, I wanted actually to comment on the summer school. It's a very, very important approach to training and mentoring PG students from the area. If you have a summer school, that would be
you are closing.
And don't confine yourself to mass. You know, we are most of us are not mathematicians. No way. Yeah, Karim has been doing also. That optimization program. I have been posting some other things to how do you used to answer my questions. So now I can post it to you. Yeah.
So thank you very much, Professor Aminu. So mildly, you've heard what Professor Aminu said. Please enhance your collaboration and linkage with your other universities. We do that. Now, okay.
Thank you very much. Let me begin with thanking the speakers that happen to be our student here at Stanford University. Actually, we are very, very happy that Stanford University is growing high and high. And wherever you see our students in the world, they are doing well. And actually, and we also, I'm also very happy that this is going together with our department. That is mathematics. I'm very happy that it's very mathematics. What I the first comment, all mathematics, the old. Let's yes. I mean, that goes together with our mathematics. And I think what I just want to expand is that maybe that was like the computer science, statistics, and mathematics. We should continue exploring and find out this younger one that we have. That we in here and they are now outside in the developed world. Let us call on our attention and see what we can do for the department and what the lecturers, the students, and the community as a whole. I just want to pose a question to both two of you. Now, you are agreeing with me with that. Unfortunately, we have everything. In terms of reading, we have everything. But that's one particular issue we are having now on ground. The example Manila is given that to be admitted, there are some programs running. He has to leave the program to run for about an hour, and so that's some days. Some days. Now, Manila and Abdul, now we are here for you. You all know we don't have the facilities, and we want it there. How do we start and how do you advise us? Because there are some, actually we want to work on research. Actually, we have some people here, they have an idea, we have idea. But how do we nurture the idea, come out with something? We don't have grants, we don't have all these machines here, computing whatever you have. So, and we still want to reach there. How do we start it?
I think the way forward is through research collaboration. When I first got to Thailand mission, I was working in the area of combinatorics and graph theory. So I later transitioned into optimization. It was a very challenging time. It was very challenging. So I went through the literature, was able to come up with a problem and how to solve it. But the challenge was the computational facts. The background here, we don't have the background of the equation very well. So the only idea that came to me is to contact someone in another country. He has worked on something similar to that. Could you please help me with the numerical experiment of this problem? And he sent me his own code and said I should multiply and see. When he sent the code was in Python. I couldn't use Python. So I ended up telling him that please, I will learn this gradually. That's the importance of collaboration. You start learning from there, but he should help me with the numerical part of the work, and we published the article together. That was the way forward. That was the beginning of our collaboration till today. And from there, I was able to learn a lot of things about the programming of these problems. So the way forward is through collaboration. We don't necessarily have the facilities, but if we can make links with other people outside here, it can definitely help. Sometimes you see students sending requests for some papers, and we try as much as possible to send the papers to them because we don't have access to some journals here. So when they send their request, you have them download and send it back. Sometimes we have them with plagiarism check. Very important as well.
Okay, sorry, 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 I just have to apologize. We have to go for the meeting. There are a few questions online. Maybe after the question, maybe Chairman can permit them to go through the questions.
Okay.
So we have budget. One question. So with your permission.
Okay. Importantly, also, if the university can secure some research grants for some people to go out there to learn, like my PhD was funded by the Thailand government. I didn't pay a single penny. It was stipend. Yes, stipend, and you have grant for this conferences. You have grant to visit researchers in different places. This also will help in solving problems like this. Whenever you go out there, you're able to learn new skills and knowledge.
But I think it's true.
Yeah.
If I can just come in, Dr. Opportunities like that are available at your disposal. Our PhD student need that opportunity like bench work, a 3 months period or in the students of an expert in the area ahead with, because maybe by that interaction when they come back, that's the end. They have understand exactly their idea and they nurture it, and then sky will be there. So opportunities like that, when they come, think about the department first before any other department in the country. Think about send it to the department and say, please, we have this opportunity available. If there are PG students interested, let them apply, and you help them. You start the mentorship yourself from there. Because when they were able to secure the bench work, it will be to your credit because you started the mentorship, and that would be relationship, the network is established. So I think it's a very opportunities like this that counts. Because if you keep silent, nobody knows. It's not like you should know you are here, you know the constraints our PG students are facing. It's not all the time that they are online. It's not something like us that we are used to that. We keep records of whatever we want to visit every day so that to see often what is happening. They won't know. But if opportunities are available, please take some few minutes, send it to Dean. Maybe these are opportunities for PG students if they can be able to apply. And that will help the department a lot. Yeah.
Thank you very much, and thank you very much, Dr. Abdul Karim, Dr. Maniru.
Is there any other question? Otherwise, we have some little questions.
I have one comment for your slide. Last slide. It's not 1 minute. It's not welcome in a situation like this. Patience. You take the mantle of leadership of the chairman yourself. Like presentation when you end by
Once,
No, come came up.
at once, I say, this is your paper, and then that, let's do that. Yeah, so.
Closing remark. Can we call for,
Yeah, Professor, I mean,
give us a closing remark.
You have a question?
About ideas from papers talking about can we have more than a single paper as an anchor paper?
Yes. It's very common. So, Professor, you can have one paper. So, Professor, I mean, please give us a closing remark, very brief. Very brief. Yes. So, out of the department or the faculty, so science, university, and then the students that are here, staff that are volunteered to come, and our other visitors, our former students. Don't need for talk given to us, and then I hope it will be a starting point for our students to join them in interaction. Yes. They have dropped their emails, so you can send them an email, and also advise please Dr. Karim and Munir, please respond to our students. Give them priority when they talk. Give the department priorities when they talk, so that we know you are busy, you have your own tight schedules, but spare some minutes and then they're able to talk to us. And we hope the initiation for the collaboration starts. Think about the summer school that Dr. Yeah, it should be what's this Friday, not pure mathematics.
No.
Yeah, it should be applied now, so that everybody can come. So on behalf of the dean, the chairman, we wish to thank everybody for having time to be here. Thank you. So don't worry, when they send you, no matter how silly it is, please respond. No matter how silly it is.
Almost 3 hours. Okay. Thank you all. The section has officially ended. We are sorry there is a break due to technical issue, but now we just round up. The contacts of the speakers have been shared. If you have any questions, comments, we can direct to them, or you reach out to the deanery, the dean, Faculty of Physical and Computer Science. Thank you. Have a good day. Bye-bye.